Well, it's been a long day. I spent pretty much all of today, minus a small nap and a really nice long run this morning, working on my presentation. Um, it's for Trepo, and it's kind of going through the tree problem as it exists and then introducing the various components of Trepo. So I'll just kind of step through what I've got so far. Still hard at work on all the artwork, but I think I got the main layout done. I'm hoping I can finish up the artwork like on Monday. I may have to work half day on Monday to do it, but I think I can do it. So the tree problem, an overview. The first thing is a tree. Is it actually a tree? A lot of people view it as like a binary tree, but it's actually not. So let's stop calling it. Let's call it what it is. And I'm going to go through these really quick because this is actually for a 50-minute presentation where I'll probably actually do 35 to 40 minutes of presentation. So blow through these really quick. Public versus private. I want my private stuff, but I want to be able to share it publicly. And some of the stuff I want public, and some of it I want private. You know, I have this weird mix where I kind of want both, and I want to be able to choose. Disagreements. You know, Inigo Montoya. You know, you clobbered my father, prepare to die. We don't want that. We want to be able to have my stuff and your stuff, and they coexist somehow. Scaling and performance. I probably need to change this. We need a performance thing. I don't know if it's really a problem or not. So, you know what? A better one would be there exists no real good solution. Okay, I wrote that one down. I'm going to change this one. And then versioning. We need to be able to have something that allows us to duplicate things, to spread it out, distributable. We need to copy things, send them out, be able to merge them back together, that type of thing. So we talk about, okay, so what's something we could use? A property graph. So we're going to introduce the concept of a property graph. It's a collection of nodes, relationships, and properties. Here's nodes and relationships, A to B to C, nodes, edges. And then we can store data on those. So an A can have like a property called size, and cool, and C, size -1, and 99 lives left, and et cetera, et cetera. So we can store data in a graph really easily. It works really well. We have relationships between people. We can even do like personas, where persons are made up of personas, which have sources. There's a gazillion things we can do with that. Needless to say, we can model what we need to model. So we also have some nice existing property graphs out there. Neo4j, Titan, Tinkerpot Blueprints provides an abstraction layer to connect to so many different backends, and there are many more than this, all of which kind of specialize in various things. So we're going to introduce vgraph, a distributable versioned property graph. So we have a regular graph, and we're going to add UUIDs to everything. In this example, I've shortened them down, made all of the nodes numbers and all of the edges letters, just so we can talk about things without having to say XYB3 5K, except for their hex, whatever. And then you go ahead and let's partition these into two repos. Let's actually put a boundary right here. So we have 1, 4, and 5 with edges B and C, you know, 3 nodes in the red repo and 2 nodes in the blue, and we have some cross repo stuff. So if we only look at one repo at a time, we end up with these things called boundary nodes, where because an edge has to have a from and a to, the from for edge A is actually in a different repo. So if we want to go look at it, we need to go to that repo. And here's what it looks like in the blue repo. They have red. So between those two, we have what we need. We're going to kind of do in the beginning, we're going to go through, I still have to plan this out, make some changes, show what commits look like, show how changes are actually tracked and done, and what it looks like when we put them on there. So that's what all of these are. So that's kind of how vgraph works. We have decap, storing and querying vgraph commits. So we store the commits and we need to retrieve them by key, date, author, repo, etc. Elasticsearch is a really good backend because we're dealing in JSON. A commit may exist in more than one store, and that's fine because of UIDs. Decap server is just a thin wrapper on a store, saves and retrieves. REST is HTML, HTTP APIs. The spec is language agnostic, so it doesn't matter. You follow the spec, you're fine. Decap client, it handles routing when saving and retrieving commits. So you can save to multiple stores, both locally and remotely, and move them between that and query multiple stores remotely. You can do whatever the heck you want. And then you retrieve commits based on the repo that it was made in. So every time you commit to a repo, that particular commit instance is tied to your repo. So here's an example deployment. We've got JavaScript client, Android clients, Java with Postgres, Node with Elasticsearch. We've got a Swift client that's running on an iOS device, things like that. So we have npipes. It's a cross-repo graph traversal framework based off of Blueprint's pipes. Allows us to cross the repository boundary when we do queries. I'm not going to go into this in my presentation. It gets a little bit crazy at the implementation level. You really have to understand how a graph traversal works underneath the covers, and I am not going to try to teach that at this. That's a 50-minute presentation in itself. I'm not going to do that. So P-tree is a set of standard models. So we're going to show a person, how we relate person with kind of these abstract conclusions. We have birth, we have marriage, and we make a lot of things first-class objects. Because we want power, granularity, expressiveness, and extensibility. So you push as much as you can up to the node and property level because it increases your granularity when you're doing commits. It also increases the expressiveness of your traversal queries as they go through. We're going to talk a little bit about how properties are stored, how they're cool, and then the whats and whys. This will be another concept. We separate them out. So why separate out the whats? So we have a what, which is what happened, and then we have a why, which is why we believe that happened. So all of the research is why we think something particular happened. And right now, in all the models, these two things are just like squished together. There's not a clean separation. And it ends up being a mess, an absolute nightmare to deal with, especially when you're trying to create specifications and you're supposed to do transport. And when people want to do research in different ways, we need to support that. But at the end of the day, we have a person that was born on a specific date. That piece, that kind of conclusion layer, should be separate and referenced from all of the whys. We're going to talk about the why connectors, how it allows multiple different why models to be associated with the same what we can do with custom extensions in P-tree. We can actually allow you to store custom whats and custom whys without clobbering anything else to be able to add expressiveness to P-tree without breaking anybody else. And because you do it on top of vgraph, you get all of the versioning right off the bat. Everything in P-tree, everything that vgraph and they all give you. And then I'm going to introduce Trepo. I have that 6-part logo where I've got the property graph on the bottom, the vgraph right above that, and then 3 columns, npipes, P-tree, and decap, and then on the top is a REST API. So I'm going to talk about, Trepo is distributed, it's extensible, it's scalable, it's cross-platform, and it's open source. And this is what I'm creating, and then I'm going to end with Trepo, the logo, just right there. Take questions, go back and forth in the slides. So that's how I'm going to do my presentation. Whew, that was a quick run through. This right here is 51 slides. I'm hoping to stay under 60. That's a lot of slides for a presentation, but luckily I'm like one concept per slide. We should be able to knock through them pretty quick. 30 seconds per slide. Just boom, 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 focus where we need to. There's enough blank stuff in here that I really want to get filled in, but that'll be Monday. I should be able to fill in the rest and then turn my attention back to the what if. The what if I'd probably go for like 1 or 2 image, like an image for each what if and 10, like 20 slides or something like that. Keep it nice and small. But yeah, that's what I did all today. I put in a heck of a lot of work. I'm tired. That's why I'm doing this a little earlier than I usually do. But yeah. See you next week. Take care.